Our solar system is home to 8 planets and nearly 300 known moons, but of those many worlds, only 2 are shaped by an active rain cycle: Earth and Saturn's largest moon, Titan. Now, NASA's James Webb Space Telescope has discovered a new molecule in Titan's atmosphere, one that may have implications for the future of this surprisingly Earth-like world. From space, Titan appears to be a featureless orange globe, with its lower atmosphere and its surface hidden by an organic haze. But when we look at the moon in infrared, its features emerge: dark dune fields circling the equator, vast plains in the mid-latitudes, and in the far north, lakes and seas rivaling the Great Lakes of North America. Unlike Earth, these bodies are not made of liquid water, but of hydrocarbons like methane and ethane, chilled to cryogenic temperatures. From 2022 to 2023, my colleagues and I studied Titan with the Webb Telescope and the Keck Observatory on Mauna Kea. Their powerful infrared vision cut through Titan's haze to reveal its northern hemisphere during late summer. What we saw were 2 broad areas of methane cloud cover around 55 degrees north, close to the largest lakes and seas. In 2004, NASA's Cassini orbiter made its first close encounter with Titan while the southern hemisphere was in summer. Cassini witnessed rain clouds forming in the drier south polar regions due to seasonal heating and evaporation. Climate models predicted that as Titan's northern hemisphere entered summer, beginning in 2017, methane would evaporate from its large lakes and seas, rising into the lower atmosphere to form rain clouds. Now, our study has confirmed that when Titan's northern hemisphere warms up, it also undergoes a seasonal cycle of cloud formation. In addition to taking pictures of Titan, we used the Webb Telescope's mid-infrared instrument, or MIRI, to study the makeup of its atmosphere. MIRI is both a camera and a spectrometer. It can break apart the light from an object to determine its chemical composition. Like Earth, Titan's atmosphere is made primarily of nitrogen, but it also has a substantial amount of methane, which plays a similar role to Earth's water vapor. Trace gases are present as well, including heavier hydrocarbons like ethane, but the details of their formation are murky. Now, Webb's MIRI instrument has shed new light on how these hydrocarbons form. When MIRI measured Titan's spectrum, it saw a previously undetected spike, indicating the presence of the methyl radical, the missing link to the heavier hydrocarbons. Here's how the process works. In Titan's upper atmosphere, UV radiation from the Sun and electrons from Saturn break apart methane into hydrogen atoms and methyl radicals. The hydrogen is lost to space, while the short-lived methyl radicals recombine into heavier molecules like ethane. Ethane and methane eventually condense into droplets and rain out of the atmosphere, replenishing lakes and seas on the surface. Rainfall on Titan has yet to be directly observed, but the discovery of methyl radicals fills a gap in our observations, and it supports our understanding of this surprisingly Earth-like world. Further discoveries will come in 2034, when NASA's Dragonfly mission touches down near the equator during northern winter. Dragonfly will drill into the icy surface to look for complex molecules made from Titan's abundant methane, nitrogen, and oxygen. Of particular interest to its search are amino acids, the building blocks of proteins that make up life on Earth. As spring slowly returns to the northern hemisphere in the late 2030s, Dragonfly may also become the first mission to witness rainfall on another world. Looking ahead to the far future, our study hints at an intriguing possibility for the evolution of Titan's climate. If the methane that is being broken apart in the upper atmosphere is not replenished from the moon's interior, it could eventually disappear from the environment. Over tens of millions of years, Titan's lakes and seas could dry up. Its shorelines could gradually give way to the encroaching desert. Its rain clouds and organic haze could vanish, leaving a dark blue sky. At last, Saturn would be visible from Titan's surface, gazing down upon a world of dry lake beds, empty river channels, and endless dunes.